In this presentation, we're going to be looking at the all-new Adaptive Aero Solver in Maya 2016. The Aero Solver provides the ability to create awesome atmospheric effects such as smoke and fire, mist. In this example, we're going to be using it to generate some smoke trails behind the laser blasts of this robot as he tries to take out our hero character. So the first thing that we're going to do is go ahead and grab a couple of objects that we want to be emitters in our new Aero Solver, and we'll grab those in our outliner. So I'm going to grab the 3 fireballs that are parented underneath the laser blasts, jump up to the Bifrost menu, and simply tell it to create an arrow. By doing it in this order and having those objects selected when we created the arrow, they're automatically added in as emitters. So the next thing that we want to do is we want to add in some collision objects. This background rock right here and this background wall need to interact with those blasts. So we're going to grab both of those guys, as well as our arrow container, jump up to our Bifrost menu, and just simply say Add Collider. So now that we've done that, the next thing that we're going to do is we're going to go ahead and just grab our arrow container, go to the attribute editor, and start modifying some of the parameters on this. So the first thing we're going to do is set that start frame to frame 880, which is the beginning of our animation here. The next thing that we need to talk about really quickly is the master voxel size. This is the size of the actual flip simulation. Keep in mind that the flip simulation is independent from the render particles. It advects its information onto the render particles. So what this means is you can have low resolution simulations transporting their information onto high resolution render particles. It's kind of similar to the liquid simulation guided workflow that we saw earlier, where you can have low resolution simulations driving high resolution particles. So let's go ahead and put that down to a value of 0.05. And with that done, we can just start our simulation. So Maya is going to take the information and send it to Bifrost to be calculated. You can see that first bar doing that. Bifrost background processes that and then starts to send it back into Maya, the results back into Maya in the form of this scratch cache. Now this is a pretty interesting scene because this is a file that the old school traditional Maya fluids would have a hard time with. It's a really large computational area that we're dealing with. It's got to have high quality. The objects are moving fast. So these are things that the old Maya fluid solver would really have a hard time with, that the Aero solver inside of Bifrost really excels at. So you can see what we have here are the actual render particles that are being displayed in our viewport. And there's a couple problems right off the bat that I want to address. So you'll notice that there's some stepping happening here. We're not really getting a nice solid trail as these guys move along. So we're going to go into our Bifrost container and start to make a couple of changes to this. One of the things that you'll notice is the time stepping has the ability to be adaptive in the Aero solver. So we're going to go ahead and make our min step be a little bit higher, and we're going to change that adaptivity value up a little bit higher so it's a bit more prone to kicking in more steps. So it's going to be in between 2 and 10, and it's going to be a little bit more prone to going to those higher numbers because we increase that adaptivity value. So with that done, the next thing that I want to do is just jump down to my air section, and I want to change this smoke threshold. This determines where the gas is. So I'm going to make this be a little bit lower. It's going to make the gas, this stuff kind of hang out a little bit longer. And we'll play this back one more time. So let's go ahead and resimulate this. So Maya again sends the information off to Bifrost. Bifrost starts calculating that in the background and sending that information back into Maya in the form of that scratch cache. So by making a couple of those changes or modifications to our scene, you can see that we now have a much nicer look to these guys. So far, everything that we've been doing has been looking at the render particles. Now, I mentioned before that the flip particles are in here, and those are driving those render particles. If we jump over to the arrow shape, which is our node that allows us to adjust the preview of our sim in the viewport, we can actually do a couple of interesting things. We could jump down here and we could say, you know what, let's just check out the component display what the actual flip particles look like. So you can see that's the lower resolution simulation that transports its information, advects its information onto those higher resolution render particles. Another way of looking at this is to look at the tile view. And this is going to allow you to see, you know, where your scene is, where is the simulation, where is the most resolution in your simulation. And you can use this focus fall off to really dial in, you know, how much of this you're going to see at any given time. So if we just zero that guy out, what we're looking at right now is level 7. So this is the actual master voxel size. That's essentially what the flip simulation is dealing with right there. So we'll turn that guy off. And what we want to do is we want to get a better looking sim on those render particles. And this is really the beauty of the Aero system inside of Maya. We don't need to change our simulation size. I know that that's good, but I'm going to modify some of the attributes on the render particles to extract a bit more information. So we're going to jump back into this Bifrost Aero container. we're going to jump down here to particle density, and I'm going to change my particle density up to a higher value. So this is a perfect example. We've got low density on the flip particles, the simulation particles. We've got very high density on the render particles. The next thing that I'm going to do is I'm going to scroll up to the top here, and I'm going to modify this master voxel size. I'm going to modify the voxel size render factor. So this voxel size render factor combined with the master voxel size specifies the resolution of the render particles. This is a multiplier. So if we put this down to a value of 0.5, it's going to multiply 0.5 times 0.05. So essentially it's going to cut it in half. That means that my render particle voxel size is going to be 0.025 now. So let's just go ahead and cue this guy back up one more time. We'll hit the simulation button and off it goes. So this is the beauty of Bifrost. As it's simulating in the background, I'm still free to work on top of it. So, I might jump back into this Aero shape here, and we'll just let it go out a few frames like that. That's enough frames for it to start kicking in here. So as I start to look at this, you can really get a sense of, yeah, those look a lot different than they looked before. It's the same flip simulation, but we're just getting a different look to the render particles because of those modifications that we made. So as this kind of scrubs through here, you get this really detailed look to this very cool effect to these guys. When they come in here and start to interact with this rock, again, it's going to look really, really sweet. So let's go ahead and just jump over to our particles, our shape tab, and let's change some of these parameters here. So up until this point, we've just been looking at the render particles. I'm going to just go ahead and shrink those guys back down. I'm actually going to turn on the voxel display because the voxels are what we would actually end up rendering inside of Mental Ray. So let's just look at how we can visualize the render settings before we even commit to a software render in Viewport 2.0. So we'll go to that Bifrost Aero material. I'm just going to overdrive this guy pretty high. We'll put it up to like a value of like 30. It's really going to crank those guys up really high. And with that done, I can go and start to increase my shadow. I want to get, some nice dark shadows in that area. I might want to go in here and maybe turn off the display of those particles. We don't really need to see those guys. And then we can jump back in here and continue to modify this. So if we just increase the absorption intensity of this guy, I'm going to darken these guys up a little bit, maybe give it a little bit more scatter, on the internal volume of that as it kind of comes in. But you get this really nice, high quality display directly inside of Viewport 2.0 before we even commit to doing a software render. So these are a couple of the things that make working with the Aero system inside of Maya just a lot of fun. It's just a really pretty awesome tool. So let me go ahead and bring up a QuickTime movie to show you what this looks like when it's all rendered out. So let's just jump over here. So this was rendered out in Mental Ray. So this is showing some atmospheric effects done with Aero. It's showing the blast trails, again, done with Aero. There's a little bit of rock hit here, a little bit of explosion happening there. Then we've obviously got that liquid simulation happening with the foam model on top of it. So those are a couple of examples of how we can work with the new Aero system inside of Maya 2016.